Okay, so we're on our last page of the review. We're almost there. Thanks for staying with us and working hard. I know it'll pay off when you take your test. Okay, number 20 says a water tank is built from a rectangular prism with a cylindrical tunnel through it. Have you ever crawled through like a tunnel like that? Maybe at the zoo where there was a tank or something and you got to crawl through a tunnel like that? Okay, the open tunnel is 7 inches in diameter. Notice that they even told us that's the diameter. That is not the radius. When we need the radius, we can't use 7. The radius will be half of that. So half of 7, or 7 divided by 2, is 3.5. So our radius is actually 3.5. Okay, so let's get a plan for how we can find the volume of this composite figure. It's going to start with the volume of the rectangular prism, but we've got to subtract or take away the part that has been drilled through and now is an open tunnel, okay? Because you can't fill up that open tunnel. It's open. Okay, so we're going to subtract the volume of the cylinder. All right, so let's get those formulas. The volume of a rectangular prism is length times width times height. Remember, it's got its own formulas because they aren't sure which side you're going to call the base. So it's just length times width times height. If I look at the picture, the length I like to call the longest one that's on the bottom, the width I like to call the other one, and the height I like to call the one that's sticking up and down. Okay, you can change the way you label them. You might have them labeled differently. It'll still work out the same. Okay, minus the volume of a cylinder is pi r squared. That's the area of the base times the height, pi r squared h. All right, so we've got our plan. Let's plug into our formula and see what we get. Length is 14 times the width is 12 times the height is 11. Minus pi, my radius we said was 3.5 squared, times the height, let's get that back up there, times our height, which we said, now let's talk about this height. We know the height of the prism. The height of the prism is 11, but I should clarify, that's the height of the prism. Are we working on the prism right now? No, we're working on the cylinder. And if we look at the cylinder's height, the cylinder height is the distance between the two bases, So remember, it's got a circular base on this side, and it's got a circular base on that side, and it's the distance between them that is the height of the cylinder. So the height of the cylinder is going to be the same as this 14 right here. It's going to be 14. You had a problem like that on your clue problems, so you've probably reviewed that recently. So I'm going to plug 14 in there for the height of the cylinder. Okay, so make sure that when you're working on the cylinder's information that you're using the cylinder's height and not the height of the prism. Okay. If we put that all in our calculator, we'll get that the volume of our composite is approximately 1,309.2 cubic inches of water. We're going to use units and describe what we're doing, so we'd be able to fill it with 1,309.2 cubic inches of water. All right, so done with the regular shapes. Now let's move on to the last topic that we reviewed, and that's the similarity ratios. These problems always show up on the ACT and the SAT. They're important ideas, good to understand. So let's take a look. It says the prisms below are similar. We know that they're similar. Find the similarity ratio. Remember, that's A to B. The area ratio, surface area ratio, that's going to be A squared to B squared, and the volume ratio, which will be A cubed to B cubed. And I like to write these down on the side so I remember, and they make sense. Area is going to be square, volume is going to be cube. This regular similarity ratio is just comparing the sides, and so the sides are just regular units. So like this would be regular inches. Okay, find the similarity ratio. All we have to do is make sure that we're comparing corresponding parts. So if I look at this 18 right here, what part corresponds to it in the other figure? That would be the 4. So if I'm setting up that similarity ratio, that would be, let's get the order right here because we need to pay attention. Are we going big to small or small to big? It says find the similarity ratio, surface area ratio, and volume ratio of the larger to the smaller. Okay, so that means they want the larger one on top to the smaller. Okay, so my larger one is 18 to my smaller one is 4. Now remember, you have to simplify your similarity ratios. So you can do that on your Desmos calculator. If you just pop that in, 18 divided by 4, and click the little fraction bar, it'll show you the simplified fraction. That simplifies down to 9 over 2. So that equals 9 over 2, okay, because 2 goes into 18 9 times, and 2 goes into 4 2 times, and so it simplifies down to 9/2. So my similarity ratio is 9 to 2. 9 to 2. All right, then it's easy peasy. It doesn't like it when I draw little shapes in place, so I'll try to not do that. I was just trying to make sure you could see that dot there. There we go. All right. So the surface area ratio then is just going to be 9 squared to 2 squared. Okay, so that'll be 9 squared to 2 squared, but we need to see what those numbers are. 9 squared is 81. 2 squared is 4, so it's 81 to 4. The volume ratio is a cubed to b cubed, so that's 9 cubed to 2 cubed. And we just need to go to our calculator and see what 9 cubed is. 9 cubed is 729. To 2 cubed is 8. 2 times 2 is 4, times 2 is 8. Okay, so that's what 2 cubed means. 3 2's multiplied together, 2 times 2 times 2. All right, and so those are our similarity ratios, not too bad. A to B for regular similarity ratio, A squared to B squared for surface area ratio, and A cubed to B cubed for volume ratio. Let's look at another one. This one says, cone A is similar to cone B. So they told us they're similar, so we know we can use all of our comparisons. With a similarity ratio of 3 to 5, okay? So that's 3 to 5. 3 to 5 is their A to B similarity ratio, okay? If the surface area, surface area of cone B is 725, find the surface area of cone A. Well, we want to set up a ratio, a proportion, where we have the surface area ratio to the actual surface areas of cone A and cone B. But if we want surface area ratio, I know surface area ratio is supposed to be A squared to B squared, and all we have is A to B. So we need to square both of those. That's going to be 3 squared, which is 9, to 5 squared, which is 25. Okay, so 3 squared is 9, 5 squared is 25. I'm going to write that surface area ratio as a fraction. That's the first part of my ratio. And then I need to decide, so it says it is from cone A, so it's A to B, cone A to cone B. So it says if the surface area of cone B is 725, cone B is 725, does that go in the top or bottom? Because my ratio was A to B, A is on top, B goes on bottom. That 725 has to go in the correct position in the proportion. All right, and they want us to find the surface area of cone A. So that's what we don't know. I'll put an X there, and then we're just going to solve that proportion. My favorite way to solve proportions is just to cross multiply and divide. So we're going to cross multiply in the direction that does not have the variable and divide by the other number. So X is going to equal 9 times 725 divided by 25. When I do that, cross multiply and divide, I get 261. What kind of feet is it if it's area? Square feet. So 261 square feet is the surface area of cone A. Okay. If you don't like the cross multiply and divide, you can do regular cross multiplication. It'll just take you an extra step, but you should get the same correct answer. Let's try another problem. Okay, how many times larger is the volume of a cylinder if the dimensions are multiplied by 5? Now remember we said if the dimensions are multiplied by 5, that means the K value, the scalar multiple that they multiply by, is 5. So it's multiplied by 5. It wants to know how many times larger the volume is. Well, let's talk about that. We know that volume is cubic, so that will mean it'll be K cubed times bigger because it's volume. And so if our K value is 5, that's just going to be 5 cubed, which if you do 5 cubed on your calculator, that's 125 times larger. Woo! Which makes sense because in each dimension, it's 5 units bigger. And so since it's all 3 dimensions, 5 times 5 times 5, that's 125 times larger. Pretty cool. Again, not too hard to remember because volume is cubic. So once we know our K value, what it's multiplied by, then we just have to do K cubed for volume. Let's try another problem. Okay. So the surface area of a triangular pyramid is 1,936 millimeters squared. If its dimensions are doubled, now this is the same kind of problem we were just looking at. Dimensions are doubled means that it's multiplied by 2. Okay, so that's the same as saying it was multiplied by. If its dimensions are doubled, it's multiplied by 2, which means we're looking at a K value, a constant multiple. Okay, that's a scalar multiple that we multiply by. Okay, what will the new surface area be? Well, surface area means that we need K squared here because area is squared. So that's going to be 2 squared. And if you do that on your calculator or in your head, 2 times 2 is 4. It will be 4 times larger. It'll be 4 times larger. Now, that's not the question. They didn't ask how many times larger it was. They asked, what will the new surface area be? Well, we can find it. We just said the new surface area is going to be 4 times larger. So 4 times the original 1,936 millimeters squared. So do that on your calculator, just 4 times that because it's 4 times larger. And we should get that our surface area is 7,744 millimeters squared. Okay, so let's talk about that one more time. If they told us it was doubled, that meant our K value is 2. Since it was surface area, that needed K squared because the area is squared. So 2 squared meant it was 4 times larger. If they only wanted to know how much larger it was, it's 4 times larger. But since they wanted the actual surface area, we had to do 4 times the original surface area. All right, last problem of the review. Whew, we made it. We did it. Okay, or we're about to have done it. The volume of a cylinder is 97 cubic feet. So that's volume of a cylinder. Okay. If the dimensions are multiplied by 3 means my K value is 3. K is my scalar multiple. Okay. What will the new volume be? What will the new volume be? Well, if it's volume, we all know that volume means we need K cubed because volume is cubic units. That means we need K cubed. So that's going to be 3 cubed. And if you do that on your calculator, 3 cubed is 27. So it's going to be 27 times larger. Remember, K is what we multiplied by. So this is telling us how many times larger it'll be. How many times larger it'll be. Now, that's not our answer. That's telling us how many times larger it'll be. So if they want the new volume is going to be 27 times the previous volume. Sorry, I thought I did it right, and it did. It just was on delay. 27 times the original volume, which was 97 cubic feet. So 27 times 97 tells us the new volume will be approximately 2,619 cubic feet. I hope you rocked the review. If you had problems with questions, go back and watch the video on that question and then try it again on your own and see if you got it correct. You can also get help from your neighbor or in Learning Lab.